And for the one in the middle, these two are TensorFlow and PyTorch. There are some machine learning framework, and they're basically the most popular ones. Okay, so here are some of the examples that I've machine learning in TensorFlow. That is including a mask detection model and race and age detection model. These two things, they're kind of similar. And what they do is I make use of the face recognition model, and then I also create another model that will allow to do mask detection to detect if you are wearing a mask or not. And then another one will be like kind of guessing your age and your race. And for the remaining two ones, those are a little bit more advanced. So the first one is called COVID detection model. And the reason that I'm calling it with this name is because it will allow the model to take in some X-ray films, and then it will identify if the patient has a COVID or not. So here are 4 example X-ray films. And as you can see, we normal person that are not professional are kind of hard for us to discern which one has COVID and which one is operation. And in fact, even for a professional radiologist, he can only achieve about 80% of average accuracy. And the last one is like about segmentation, and yeah, it's like a more advanced application. So I've been talking a lot about like how and what we can do with machine learning, and today's topic will be about machine learning in TensorFlow. So let me talk about what TensorFlow is. So TensorFlow is a machine learning framework, and you can kind of treat it as an IDE of the machine learning language itself. Like it kind of like a Visual Studio, and machine learning is like the C++ or the Java that you use to code with. And the reason that we are using TensorFlow here is because TensorFlow has a very easy to use API that it will allow anyone with no previous machine learning experience to get hands-on very. And another good thing about TensorFlow is also support Python, C++, and Java. And if you are like a web developer, it can also be used with JavaScript. Okay, so let's jump to the topic and talk about what machine learning is. So I guess most of you will be thinking like about maybe an AI, or maybe some of you will think that it's kind of like a black box that will allow a machine to learn. One fun thing is that like recently I kind of read an essay saying that people will maybe in the future will allow to use machine learning to make mathematic discoveries. And some say that, oh, you could use the machine learning to create a gravitational model and that kind of thing. But yeah, so is it really true or not? We will find out soon. And if you have heard of machine learning, maybe you will have of these 2 terms like deep learning or decision tree. And here we got 2 slides this is like talking about the difference of machine learning and deep learning. And here, what it meant by machine learning, it just means the traditional method of doing machine learning. And deep learning is like a more advanced algorithm. But both of these are also categorized as machine learning as well. So before we go into deep learning, I kind of want to talk about how the traditional method works. So a traditional method will require, and that is the target that we kind of want to have our model to work on. And then there will be a manual process of feature extraction. And for this example, like when we have an object, and if we want our model to predict if that object is a vehicle or not, we'll go for a manual process of like extracting the features. That is like, I will be telling the model, hey, this object has 4 wheels, has a framework, has window, has engine, blah blah blah. Then the model itself is going to take that in, and it's going to do classification and finally give us the output. And what deep learning is a more advanced method, and also a way that is closer to our human brain. And the reason I'm saying that is because a deep learning model, it will only require the input itself, and it will do everything else and give output. That is basically like us. Like if we see a car, and then we can immediately tell that it is a car. And same for the deep learning model. Learning model will be able to like do the feature extraction part as well. That is, it's going to see the patterns inside the object. And sometimes it will be also be able to see some patterns that we human being normally can't see. And here it is a picture of how the deep learning network looks like. So here we have basically three major layers. That is a input layer, a hidden layer, and an output layer. And as I just mentioned before, input layer is basically the input or the target that we want our model to work on. So with the input layer, the model is going to take inputs or take information from this one, and then it is going to be processed by the hidden layer. And in this picture, we can see that there are some like hollow circle stuff, and these things are called neurons. And we can also see that each neuron is actually being connected by each previous neuron in the previous layer. And in each connection, there are certain ways that the neuron will take those information in account. The method that it applies is called weight and biases. So it's kind of like, imagine that like I'm telling you that an object has a window, it has wheels, and then it has engine. And if I want to ask you what's the key factor that you take into account for determining if that object is a vehicle or not, I guess probably many of you will be saying that it's the wheels and the engine, right? Instead of just a window, because a lot of stuff could have a window, right? A room can have a window, a house can have a window, blah, 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 a lot of. And that also applies to the deep learning network, because in the deep learning network, it also need to be able to learn a lot of complex pattern, so that it will also have to weight different information into account. And in the way, one of the way to do that will be through the weights and biases. And with the weights and biases, it is then in the neuron itself, it is going to process this with an activation function. And the activation function, the reason that there's an activation function is because it is going to take those input into account, and then it is going to give these inputs a nonlinear complexity so that it can generate another output for making accurate decision. And the reason that why we need to give a non-complexity into the layer itself is because that, like, imagine that we have a glass or a mirror in the picture. If you want to know that if that thing is a mirror or not, we kind of have to like look at the color itself, the transparency, the contrast to the surroundings, and is it like reflecting anything in the picture, blah, 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 a lot of stuff. And instead of just saying that, oh yeah, it's in a rectangle, it's in like a square or mirror, or a circle shape, so that's just a mirror. And that applies to the model itself, because we kind of want to deploy the model for a more complex problems. And so we want to give the network itself a capability of learning a very complex pattern. And that's why we also need an activation function. And here, it is kind of like how the network itself works. And yeah, by the way, the whole deep learning network is called a neural network. And the reason why it's called neural network is because the network itself has a similar structure to our brain. And yeah, and that's also why this circle stuff is called neuron as well. So here, this picture is showing it has something to call a forward pass, or you may call it forward propagation. And the forward propagation is going to first take the information to account, and then in each neuron, it is going to generate an output signal to the next neuron in the next layer. And then the neuron itself, after receiving the inputs, it is going to generate another output. And then they're going to connect every neurons in the layers and doing it so on and so forth. until it reach a output layer. And the output layer is like how it is named it. That is, it is going to be the layer that where we fetch the output from the model. And this is still not the end of the story, because we are just talking about how the model can do prediction, but we didn't quite talk about how the model itself can do the learning process. And the method that it uses to do the learning process is called a backpropagation. And for first thing in the backpropagation, after a forward propagation, in the output layer, there will be a loss function that the model will be applying. And with that loss function, it is going to calculate a loss value. And the model will try its best to modify all the neurons, weight biases, and the parameters between each of those to lower the value calculated by the loss function. And by doing that, the model will be able to achieve the target of learning, making the accurate prediction we want. So one thing we want to know is that a loss function is very important. This is an indicator and also instruction for the model on how it should be learning on different kind of stuff and the prediction that it should be making. And yeah, so now I have basically talked about the basic of machine learning and deep learning. And if you have any questions, you can just type it in the chat, or you can unmute and let me know.
I have a question. How long did it take you to like learn all of this from like zero to what you know now?
Oh, yeah, it's probably going to take months, because you don't really have the kind of course in a college, and normally you will have to take them in a master or a PhD degree courses. So if you are going to do self-study, it really depends on yourself and the materials that you have. But personally, for me, it took me like at least 1 to 2 months.
Yeah, guys, any more questions?
Yeah. Some question? Oh, right. That's a good question. How did I come to machine learning? Actually, the first thing that I've heard of machine learning is because of Tesla. So if you know that like Tesla has this autopilot front is very popular and famous about like its accident and also sometimes how it saved people's life. And when I like kind of read some materials about how Tesla do that, then the term machine learning naturally pops up. And when I get to know more about it, yeah, then I started to feel interested in it, and that's how I got into machine learning. Okay, so I guess we are fine now, and I'm going to continue. So for now, we are going to create our first machine learning project, and in order that we are going to use a Google Colab and implement Tensorflow. And by the way, today we will be coding in Python, since Python will be the way of using TensorFlow. Yeah. So right now I'm going to Google Chrome and I'm gonna type Collab. And yep. So let me make a new notebook. And yeah, by the way, for those of you who don't know what Google Colab is, Collab is a notebook that will like kind of allow you to make programming a code block by code block. That is, it won't be like running the whole thing by one time and then end it, but instead it is going to save the status of itself after running each code block so that you can do it one by one. I mean, bit by bit. Yeah. So here we are going to import Tensorflow here. And since we'll be using NumPy data, so I'm going to also add this command. And I'm also going to use matplotlib as PLT. All right, NumPy plots. I didn't get it wrong. Oh, of course, tensor risk. Okay. Oh, yeah, by the way, today we will be working on the MNIST MNIST dataset that is it contain a list of image with a handwritten digit. And our goal of today is to create a model that will be able to recognize those handwritten digits. And at the testing it with our own data. That is, I'm gonna just draw a handwritten digit and have our model to do prediction on it.
Matthew, two questions. First, can you zoom in, please, a little bit?
Oh, yeah.
And second, can you share the link, please, in the chat?
Oh, yeah, sure.
Oh, I think, can you grant access to everyone?
Yeah. Okay. Change link. So, USB editor. Right.
Just don't mess with it.
It's still not letting you guys do it?
Work, yeah, it works now.
Works now? Right. Great.
Cool.
So the first step is we are going to fetch the data set from TensorFlow. Data set. There's something. Great. People can access it. Right. So from the data set, we are going to get a group of train images and also train labels that will be used for the model to do this learning process. Labels. Sorry. Load data. Right. Okay. So after getting the data set, we will start to build our model. And the first step, we will be using the Keras layers sequential. That will allow us to allocate a space for our model. And here we will have a space for a model, but now it's still empty. So if you still remember, just now we talked about the structure of input layer, hidden layer, and the output layer. And now we will have to add the input layer for the model first. And by doing it, I'm going to use this command. And here I'm using a function called flatten that will allow us to compress the whole image into from a 2D information data into just one dimension list of data. Because here, since the data is not really a complicated one, so that we could just like kind of compress it and have our model to do computation in a higher speed. Oh, by the way, I can actually show you the how the data set itself look like. Yeah, so this is kind of like how the data set looks like. So this one obviously is a handwritten digit of 5. And as we just mentioned, after input layer, we need to give our model another hidden layer that will do the processing of the information. And in order to do that, we will be using a command that is called layers.lens. And here we are going to give it 128 of neurons. And the way that we get this number is kind of like from the previous researchers, and the way that they get it is just by doing experiments. Yeah. So one thing you will want to know is that when making a model for a project, there's no golden formula for finding the best number in your model. Most of the time, you just have to guess it and make more trials. And lastly, after the hidden layer, we'll be adding a layer of the outputs so that we will be able to know which number it is guessing. And yes, since they're going to identify the handwritten digits, that is going to be from 0 to 9. And in total, there will be 10 digits. So that's why we will be having 10 neurons here. And here we are going to use a sigmoid function. Oh, by the way, for the kind of activation function that we should be using, it's kind of there are laws that you can use, and if you want to know more, you can just go to the Tensorflow web page and look for how each function works and determine which one works the best for your model. Okay, so right. Yep, I don't need the layers. Right. So for now, we will be comparing the model, because just now we talked about that our model needs a loss function for doing backpropagation, and basically what we just did is just that we give our model like the backbone structure only, and here we will need a optimizer and also a loss function so that the model itself could really runs. And what the optimizer does is it just basically optimizes the whole learning process by minimizing the effect of loss function on each parameter. You can basically just treat it as like optimize the whole backpropagation process. Optimizer equals losses, and loss function we are going to use this sparse categorical cross entropy, and this loss function for this one, yeah, it will be suitable when you have like multiple output. And here, in order to help us to look at the result of the model easier, to give it a matrix attribute, and that will be the accuracy. Okay, so let's see if this time I make any more mistakes. Okay. Oh, it works. So finally, come to the training process of our model. So I'm going to fill it with a bunch of training images and also the truth value so that it know the feedback and to do the learning process. And we are going to have our model to go through the data set for around 10 times. Okay, so here we are going to test our model with the test data set and see how it actually goes with the prediction. And you may wonder why we are doing this step. Isn't that it already shows the loss value and the accuracy in the training process? And the reason that we are doing this step for evaluation is because there's something called overfitting in the model that could happen sometimes. That is, instead of learning the pattern inside the data itself, the model is kind of like memorizing the answer for each data because we have been trained 10 times, so it kind of may be possible that it remember a little bit of, and that's why we want to do the evaluation of it. Yeah, so here we can see that is getting us around 95% of accuracy. That is not very bad, and a little bit lower than the 95% we got here. Okay. And yeah, so let's see if our model is really giving us the right answer or it's just something wrong with the data set. And so this one, we can see that it's a handwritten digit of 5. And let's fit in this image and see if it really gives us the answer of 5. Okay. One thing you want to notice is that when we fit in the data into the model will treat it as a batch of data. So normally, if we just want to do like prediction on only one data, you have to actually add a dimension of attribute that is for telling how many data is in the batch. So that's why we are using reshape function here. Right. Okay, so oops, we are not getting the right answer for this one. Seems like this is where the 5% go. And let's see if without this MP dot argument max, let's see what we got here. I missed out the bracket here. Okay, so here you can clearly see that we have 1, we have 9.99 something here. And this is basically the probability that the model think that data should belong to. That it can kind of give lots of 1 here. That is weird though. But that's okay. Because we can see that we didn't get 100% accuracy. So it could happen sometimes. And right now, what about let's try to see if the model is also doing a 95% of accuracy by creating our own data. And now I'm going to open up the Paint application, and then I'm just going to create a new handwritten digit. All right, guys. So yeah, can you all give me a number that I should be testing with? well, since it's 5 o'clock now, okay, yeah, right, 9. Okay, let's try with 9. Okay, so oops, very agree 9. So yeah, so we got 9 here. Oh, sorry, since I closed it, so right. Okay, right now I will have to upload it to Google Cloud, and then I'm going to test it with the model. Right. So let me see what's the command of mounting the Google Drive. Right. Yeah. Okay, access permitted. So here we are going to read the image with the CV2 module. .png, and yeah, I'm going to give it a number 0 because we want it to just treat it as a black and white image. Yeah, we're going to do a little bit of pre-processing on the image. So we can see that here the image is black and white, right? And just now the picture I draw is actually in white and black, so it's like a total different color. And here we are kind of going to reverse it so that it will be like in the form of in the form of data that the model used to know. Okay, and I'm going to divide by 255 because we want to normalize the value of the image. And here, with number that is 0, it equals to 1. Share with number that is 1, it's going to be equal to 0. Right. So with this, able to like kind of from white and black image to black and whites. And let's fit in the image to our model and see if the reverse or the accuracy is just a fake value. So here it's kind of a lot of similar value and it's hard to read it. All right. So let's see. Oh, it's not reading it. Too bad. Our model doesn't seem to be achieving the way that it should be doing.
Maybe try another number.
Yeah, sure. I mean, let's say we just try with another image. Wow, is this free? Yeah, this should be free, right? Oops, to that. Looks like I'm not really doing its work. But that's okay, because we know that the model sometimes is not really going to do a very accurate result. And most of the time we will have to like keep on doing improvement by maybe changing the numbers here or changing the function we use, or maybe even making another structure. Oh yeah, let's see if we try it. Like another number if it works. Maybe just that my handwriting is too ugly and it can't recognize it. Okay, this time let me try with 7. So upload it. Okay, let's reload our drive. And let's try another picture. And nope, still not working to that. But yeah, this is basically it. And this is basically how you implement machine learning in TensorFlow. All right, so.
Can you try 4? Question in chat.
Oh yeah, sure. For okay, and we try it. Oh, wait, why did I get disconnected? Oh, wait. Um, let's try another image. Okay, so this is like a third time and see if it's really working or not. Oh, okay, this time it works. And yeah. So basically that's it. Like even though we see like a very kind of beautiful number here, 95% accuracy, it doesn't really guarantee that every time it is going to give us an accurate result. So yeah, and machine learning is something that is about like you keep on trials and getting errors and then just making improvement on it. And it was seems like we have overrun that a bit. And so, all right, if you guys have any questions, you can just unmute yourself. And again, you can just type in the chat and now I will be answering all of them. well, good question. How did I get my internship? So, so yeah, so data science intern is really kind of a job that you really need to try hard to find. And I just get really lucky that I somehow find my company that it kind of like not looking for a student that has a very much experience or is like coming from a very prestigious school, and they are also willing to give me an opportunity. And well, one thing that they're willing to give me opportunity is because they kind of see my project, that is my mass detection and stuff, and they kind of think that I might be able to assist them with their AI production stuff, and that's how I get my internship. But basically, you just have to try hard and see. And if you get lucky enough, you will be able to find your own internship as well. Which project do you most enjoy doing? So well, speaking of which project I most enjoy, it will be the one that I actually worked the most recently. That is like the hard segmentation project. So the hard segmentation project here is actually, yeah, it's actually a very complicated one because it really requires a bitwise identification. That is, so just now we see that our model is kind of actually making a prediction with a value, and I will have to do like the predict. I will have to make my model to do that kind of prediction on each bit. I mean, on each byte of the pixel. I mean, on each pixel of the image, and then to identify if that kind of belongs to each part of the heart. And that's how I do the heart segmentation. And also the structure that is applied in that project is also a very advanced and also a very complicated one. Yeah. So did I call it now to look for internships? Well, I kind of sent out a lot of, yeah, I kind of sent a lot of application to a different company, and it just said that my company I'm working on right now is kind of happened to be one of the field that replied to me. All right. So is there anything else?
What was the interview like for the company?
Oh, well, speaking of the interview, it's kind of interesting that they didn't really ask me much. They didn't really like do a proper interview. They just kind of like want to see the project that I did, and then I just kind of show them the like the mass detection thing I did. And yes, by the way, for a company is a company called Oak3 Technologies, and I'm kind of now doing a remote intern for that. I think I can show you my project actually. So yeah.
Are you sharing now? Because we can see the presentation.